So the first rule of line structures says that every line end is a carbon. Looking at this line here, ask yourself, how many line ends do you have? Well, we have one, two. We have two line ends. Therefore, we are going to draw two carbons. Specifically, two carbons that are covalent bonded to each other. Now, are we done here? No, because you know about the octet rule in chemistry. Carbon needs to satisfy the octet rule. But what do we draw these? What are we connecting the carbon with? Well, here comes the second rule of line structures. The hydrogens on carbons are implied, meaning that on this line here, there are hydrogens, but they are implied, means they're not being shown. So we're going to connect the carbons with hydrogens. You simply draw a line to represent this entire molecule. Now, what if I just draw a dot here? Well, this still counts as a line end because it is an end. So how many carbons do I have? I have one because I have one end. And remember that the hydrogens are implied. So by octet rule, we are going to connect them. We're going to connect the carbon to 4 hydrogens to satisfy the octet rule once again. What about this structure here? Well, the first thing you should do is look at the number of carbons. Ask yourself, how many carbons do I have? I have 1, 2, 3. I have 3 carbons. Therefore, I need to draw 3 line ends, and the hydrogens are implied, so I don't have to draw them. So you simply draw lines. The line structures are called line structures for a reason. So you draw lines, and you ask yourself, how many ends do I have right now? I have 1, 2. Not enough. We need 1 more. So we're going to connect. We're going to connect the line with another line. And you ask yourself, how many ends do I have now? 1, 2, 3. And we are done. Because we have 3 line ends, which means we have 3 carbons. And the hydrogens are once again implied. What about this molecule? Well, you count the number of carbons. 1, 2. How many line ends? Just 2 line ends. So a line should suffice. What about double bonds? Well, you still first count the number of carbons to determine the number of line ends that you should have. You have 2 carbons, 2 line ends here. So for double bond, you simply just add another bond. These lines, remember, they represent covalent bonds. They're bonds. So they're not just useless. These lines are bonds. So if you're double bonded, then draw 2 bonds. And the hydrogen, once again, are implied, so you don't have to draw them. What about triple bonds? Well, first, count the number of line ends you should have. I got 2. So we draw a line to represent 2 carbons. And if they're triple bonded, well, just draw more bonds. That's it. Hydrogens are implied. What about heteroatoms, like oxygen? And other heteroatoms are, say, nitrogen, oxygen, like here, sulfur, and the halogens. So, first thing first, still, you count the number of carbons to determine the line ends. 1, 2, 3, 4. So, we draw a line here, and ask yourself, how many carbons do you have? By counting the line ends, I have 1, 2 line ends. So 2 carbons here, and this carbon right here is bonded to an oxygen. So you need to show this bond here by doing this. It means this carbon, which is implied by the line structure, is bonded, right? Is bonded to an oxygen. Don't do this because there's only one line end here, which is this one. This is not a line end. And you can even determine that just by looking at the number of bonds. We have one bond here, which is one line. You need another bond to connect it to the oxygen. So you draw another line and connect it to the oxygen. And you look at this line is bonded to another hydrogen. So you start from the oxygen and you draw a line. How many carbons do I have? Well, how many line ends do I have? 1, 2, 3. I have 3 carbons. So we need to keep going because we need one more carbon. So we connected like this. And in the end, you check it. 1, 2, 3, 4. 4 line ends means 4 carbons. And the hydrogens are once again implied. And you can draw the lone pairs here if you want. Well, let's move on to this structure here. First thing first, you count the number of line ends since this is a line structure. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You have 10 carbons that you should be drawing. So let's draw 10 carbons. 1, 2, 3. And add the hydrogens. And I will let you struggle with that, okay? What about this structure here? First thing first, count the line ends. 1, 2, 3. Remember, this does not count as a line end. So we have 3 carbons. So draw the carbons first. 1, 2, 3. And I have an oxygen that's attached to this carbon here that is double bonded. So I'm going to draw a double bond here. If you want to show the lone pairs, you can. And this line represents that this carbon is connected to this oxygen. So we draw this line here and connected to the oxygen. When you see this OH here, it's actually O bonded to H. And once again, you can draw the lone pairs here if you want. And don't forget about the hydrogens that are implied. Okay, moving on. First thing first, 1, 2, 3, 4, 5, 6. This is not a line end. So 1, 2, 3, 4, 5, 6. We have 6 carbons that we need to draw. 1, 2, 3. 6 carbons. I'll let you struggle with the hydrogens. Okay, notice that this needs a hydrogen here because of octet rule. So they usually try to trick you with structures like this. There is a hydrogen here because of the octet rule. You can't just have 6 electrons or 3 bonds. So, so what do we do with this chlorine here? Well, look at this. Oh, you look at this. Sorry, you look at this. The carbon is connected to the chlorine, so you need to draw this bond here. So you draw that C is connected to chlorine, and get the lone pairs out. Now for this structure right here, you may be wondering, why do I have a hydrogen if they're implied on this molecule here? Well, you see, only these line ends could imply hydrogens. This is not a line end. These are not line ends, and this is a hetero atom. So if they don't show you this hydrogen, that means the nitrogen is not connected to a hydrogen. So the only way to show this, the only way to give this nitrogen a neutral, no charge, is to attach a hydrogen here. So once again, we count the line ends. 1, 2, 3, 4, 5, 6. Okay. Therefore, we need to draw 6 carbons. 1, 2. 1, 2, 3, 4, 5, 6. 6 carbons. Now I'll let you struggle with the hydrogens once again, but we need to draw this hydrogen here along with the lone pair because the octet rule. Two electrons in this bond. 2 electrons in this bond. 2 electrons in this bond. 6. We have 6 electrons so far. Two additional electrons here. And once again, the implied hydrogens. Finally, we're going to look at benzene. Once again, don't get intimidated. Count the line ends. 1, 2, 3, 4, 5, 6. 6 carbons. I have 6 carbons here. The double bonds, you don't look at the line ends. They're just bonds, okay? So only single bonds, you look at the line ends and you do the rules. So in here, if I have a double bond here, just draw them. There's a double bond, and here's a double bond, and notice that there's these implied hydrogens. And we are done.